Hello and welcome to this episode of the Frankenstein mill. This is the episode where I actually put the mill into its housing and complete the project, or near complete the project. So what I'm doing here is I'm putting an aluminium base plate in because I had the piece of material there and I thought it'd fit all right and look nice. So what I'm doing here is I'm disconnecting the control electronic box that I made for it, and now I'm actually dismantling the mill itself because it's just too heavy to lift as one unit, and it's pretty heavy lifting it as two units. But I think all up it's about 70 kilos, which is about 150 pounds in the old money. So anyway, I give it a good old lift and carry it over to the machine there. So now I'm just taking the base or the X and Y part off and just offering it into the enclosure and squaring it up and lining it up to drill through pilot holes. Oh, first of all, I decided I'll put the interior light. It's a 40 watt equivalent of, no, it is a 40 watt LED light, and it's a good light for inside the machine area there. So I'm squaring the machine up here, and I'll drill pilot holes through, and I put very large type wood screws. They're like wood bolts rather than screws, and they're more than man enough to mount the mini mill inside its enclosure. And it's not a bad job, it's not too heavy for one person, but it's about the limit, I think. So now I'm bolting the column back on. And it goes nicely back into place. It's not really doweled, but you can't actually get the bolts in unless it's perfectly right. And torque them down pretty tight. So there it is, basically in the enclosure. So now what I'm doing is I get a piece of 75mm thick wall PVC piping, which was about a yard long, and so about 6 inches of it are going to go down inside to the base there, and the rest is going to be sticking up inside the enclosure because I don't want any sort of fluids going down inside with the electrical. And I'll run some silicon sealant around the base of that. So I'm just running the Y cabling now around the base line then to the Y motor over there, and I do the same with the X and the Y, and just keep it up on that ledge that I made. So I'm putting some protection for the cable. The small cables here for the stepper motors. I'm not sure what it's called. It used to be called Spiralex or something like that. You leckies out there will know exactly what it is. Just to protect the wiring, and I zip tie it all up. And I got a junction box there as well, a junction block rather. So I run mains power up as well for the main spindle motor and for that light. So when the main power is on, the light will automatically come on, because you always need good lighting inside these machines, so you can see exactly what you're doing. So the next job I do is I have to take the emergency stop button out of the enclosure that I made, because I need to mount that actually on the outside of the panel work, because I won't be able to get at it down in the side at the bottom there. So I take it out and take the wires off it and extend the wires up to the switch, which I mount later on the front of the unit. And here I am. I'm actually making the box part here where I put that switch in, and I'll mount that box on the front of the unit, somewhere easy to get to, like there. And it's very easily mounted. It's just a couple of screws. They don't quite go through all the material there. And get it as square as I can. And then drill a hole in the middle that I can put the cable through. And then screw it all up. It's actually got a weather seal on that lid as well, so if there's any coolant splashes out over, it's not going to interrupt with that at all. Anyways, DC voltage is running through that anyway, so it doesn't really matter. So the next job I do then is the wiring coming from that box and the Y-axis drive motor. I put some cable tacks on it just to hold the cable up firm out the way, and I'm actually just joining the cable that comes from that box, and I'm just going to, that's the cable there, and I'm going to connect it onto the front of the control box there. In fact, I'm just going to place all the cables just over the back there. I do actually zip tie them all up out the way later, but just to try it, I just placed all the cables back there and pushed the computer, which is on the right hand side, and the control electronic box then, which is on the left hand side, and I separate them here because there's fans in both units to keep them cool. So I wanted to separate them to give them air gap, and I'm just connecting up that dead man switch now. I just put a couple of bullet connectors on there, which is really all it needs. And well, that was it. So then what I did, I had a nice 12 or 13, I think it's a 12-inch flat screen, just a normal type of monitor, but a good one. And I put it on a piece of MDF actually, and I mounted it where I thought I'd like to see it. And then I had now this is a on-off switch, main on-off switch, and it's like a Y cable. You've got power feed coming in, and then it goes to the switch, then goes back out to another plug, which you can connect into whatever you want to switch on and off. And I got a big junction box then down behind the computers. I don't know whether you saw it earlier, and this main switch switches everything on and off. So this is a ledge little bench I made to put like the mouse and the keyboard on, and I couldn't hold it square, so I just called Steve, and he came and held it for me, and I screwed it up nice and firm. I used some metal L brackets. I put 4 on actually, and I put this one on around here too. Now, if you're going to put a screw in plywood, drill a hole in first and use the finer type screws. Otherwise, it'll just separate the wood. There you are. There's one of those fine screws, Okay, well, it's all connected up. You'll notice that there's been a screen change. I actually fired the computer up and found that the screen was a bit crackly, so there was a problem with the screen itself. So I've changed the screen out. I'm going to, over there I've glued up a 45-degree angle shelf to have this here. Because I think I preferred it that way, it would be better for me. I've got an emergency stop button strategically placed there. I've got a mains on-off switch here, which goes down to a main distribution board inside. Everything's all fused, so you know, any problems and it's all going to shut off. You know, you can't be too careful, especially with 240-volt mains power. So it should work. So let's see if it'll go home. Here we go. The Frankenstein mill is alive. It's not totally finished. What I'm going to do is I'm going to cut perspex doors here and the sides. They're going to be on hinges, and just screw the back on really. I do have the coolant to finish, but I've ordered a coolant nozzle, but it hasn't come yet. I don't know what's happened. It's stuck in the post somewhere. So I'll probably make a very short video of using the laser to cut the doors out and fitting up the coolant, but essentially it's pretty well there. So I thought, you know, you'd see it. The only other thing I've got to do is just knock the corners off here, just a little bit of fettling here and there, but it's there. At this point I'd like to tell you a little bit of, well, some big news actually, for my company Pacific Tooling. As you know, a few videos ago, and I've made about 20 videos now, converting this, how to convert it and what have you. We found that a small machine like this is probably limited in its use. I mean, it's got a fairly good work envelope, but it's fairly limited. It's only 350 watts main drive power, you know, and it's a good machine for what it is. But the big news is, and I'll tell you the big news first. We, in the background over the last 12 months, my engineers have developed a decent size CNC milling machine. Just to give you some idea of size, the drive motor is 1100 watts. That matches the Tormac 1100. That's why they call it Tormac 1100, because it's a 1100 watt drive motor, main spindle drive motor, which is 1.5 horsepower. So we've matched that. The engineers have designed it so it will take a full-size 6-inch vise or 2 5-inch vices, but my preference is 2 4-inch vices. But just to give you some idea of size, it will be available in stepper motor and servo motor. My particular demonstration machine, which hopefully will be completed by the end of this month coming, because it's the last day I think, and will be shipped out to me, so you'll be able to see it in about 2 months' time, I think. My machine is servo drive. It also has a servo drive 4th axis. And I say we're matching the 1100 for spindle motor size, and in general size actually. You will be able to purchase it on its own base without paying extra. So the machine and base come as a unit. It's PC based because, and I'll put some links up to some people talking about the Skyfire, for instance, that they bought, and they have a dedicated controller with it, and they're very disappointed in these machines because the controller won't handle 3D machining, so they're very limited in the actual controller unless you go to a Siemens. Now that alone would add on about $3,500 US. So we're thinking, okay, people are used to Mark III and Mark IV for that matter, PC based. That's what we're going to go for, because we're trying to hold the price down as much as we can. Saying that, actually, compared to a Tormach 1100, we're half the price. So, or thereabouts. So you get a good deal. We actually build it in a steel cabinet, similar to this, but it's obviously slightly larger to accommodate for the machine. And as more information comes along, photographs, video, what have you, before I get my machine, I'll put it up so you can see. So there we have it. A little bit of news and the pretty well completion of this this job. And thank you for joining me. And if you press the little red box down in that bottom corner, that'll take you to my YouTube channel, where, well, actually there's 2 channels. There's the Australian Inventors Workshop, this one. There's the Australian Inventors Laser Lab. I've just running out of room on the one channel, and everybody wants to see about lasers. So that's why I started up the laser channel. However, that one is probably going to be receiving some CNC milling videos as well, because like I said, I'm running out of room on this channel, and people, I don't think, like scrolling through 300 or more videos. So there's that. So most of you know, in my channel there's videos on CNC mill conversions, CNC routers, lasers, wood turning, general shop jobs that I do around here. So I think there's something there to interest, you know, everybody. And I'm told by Google that more and more schools and colleges actually are watching my videos, which I think is fantastic. You know, get the younger folk sort of involved in this sort of tooling then, and what you can do with them. So thank you for watching, and until next time, it's bye for now.